So this is Rendering 1, Part 3. We're going to talk about D3D. We'll be using D3D 11 in this class. But I want to stress this is not a class to teach how to use DirectX. We are using DirectX as an example of one of many of the graphics APIs. We'll be talking about how graphics APIs work and what the commonalities are in them, and then use DirectX as an example of how to look up how to use the thing. So the first thing we want to do is initialize DirectX. And the first step of that, I'm going to say, is to set up the window. So the window, I already set up the window in the lab for you. You don't have to worry about that one too much. Now let's set up what's called the swap chain. We just talked about what a double buffer system is, how that looks like. We now need to set one of those up. So we'll need to ask the system to set us up this double buffered swap chain, and we'll need to tell it what resolution we want and what the color format is and whatever other parameters come up in that. So when you're getting started with your graphics API, you're going to want to look into the documentation and dig up how to initialize the thing in the first place, how to set up that double buffer, and perhaps the word swap chain is a good place to start. So a note about before we look at the web page, the modern graphics APIs have a lot of parameters. I mean, they give us more parameters every year, so it's getting really crazy. In DirectX, the way they deal with so many parameters is they pack them into a structure. So when you call a function, you pass all your parameters pre-packed up in a particular structure. And to make that structure a little bit easier for us, whenever they have a default option, they try to make the default value 0. So if you just put a 0 there for that default value, you'll get the default behavior if there is a default. I mean, like, you're not going to be able to put like a default resolution of 0. Resolution of 0 doesn't make any sense. So you need to fill that one in. But there's times when there are optional parameters, and if they're optional, 0 usually work. So there's a 0 memory function. That's a function call you do, and you just give it a structure, and it fills the whole structure with 0. So that's a good place to start if that way you don't have to fill in everything. Okay, let's take a look now at this link here that I've already looked up. This is straight from Microsoft, how to initialize a DirectX 11 device. Here we are, just Google for how to create a swap chain in DirectX 11, and this is where you'll find something like this. This is Microsoft's page on exactly how to do it. So they'll tell us how to fill out the swap chain structure. This is the name of the structure that we want. And like I mentioned right here, you declare one of these on the stack and call 0 memory on it. That fills it all out with 0. So if you want to use a 0 value for any of the parameters, it's all filled in. I'll take a moment to point out this size of. That's something we'll talk about some more. It's very handy. It just tells you the size of the given structure. 0 memory doesn't itself know what kind of structure you're going to give it. It just takes an address and fills in that number of bytes. So we'll need to tell it how many bytes that is. All right, so there's all these parameters to fill in to the swap chain description structure. We will want to make a few changes to make it match our needs. We are not using a 640 by 480. I just follow the lab notes on what it says to do. I think it's 800 by 600. Everything else should be good. The output window, that is a variable that'll be passed in. We did not call ours G_hwind because we're not using a global variable for that. So you can look out for that to change. So you create one of these structures and then you use it to pass in to the create device and swap chain function. See how we passed it in right here. There's a bunch of parameters on here in addition to fill in
and you should just be able to follow along with this page. Here's a note about how to use like DirectX 11.1. We don't need that for our labs. Just stick with this first one here is just fine for us.
All right, now that we're initialized, let's start talking about the back buffer. When we talked about the double buffering, we talked about the front buffer, we talked about the back buffer. The back buffer is what we need to draw onto, so we'll need some way to ask the graphics API, hey, give me the back buffer. So go Google that and you come up with your swap chain, which we just created, has this function get buffer. That's the back buffer. That's how you get the back buffer from the swap chain. Now that we've got our back buffer, we're going to want to render onto it. We're going to draw on the back buffer. So to draw on something, we will need a render target. So a render target is what you want to ask for. And in DirectX 11, here we go. We use the DirectX 11 device and we call the function create render target view. So look into how that works and you'll see exactly what parameters you need to pass and how it gives it to you back. The point is we are looking for a render target. We have the back buffer and we need to turn that into a render target. And here's a note, just a note on DirectX and how they happen to use the word view. They tack the word view onto things. What does that mean? It means we have a block of data. We have something like, in this case, it's a texture. We have a back buffer. Back buffer is a texture. What is a texture? A 2D array of pixels, right? So that's like, let's say maybe that's 3 bytes per pixel, a byte for each color, right? A red, green, and blue for each pixel. And then we have, say, 800 by 600 array of pixels. So what we have is 3 times 800 times 600 bytes of data. We can create a view into this data in which it is structured in a particular way. It's structured as a render target. And the render target is an 800 by 600 pixel view, right? So that's what view means in this case. Okay, viewport. Now that we've got our render target all initialized and ready to draw onto, there's still more. You think that's enough, but that's not enough. Now we need a viewport. The viewport says which part of the render target are we drawing onto. In our case, it's very simple. We just want to draw onto the entire render target. Just use the whole thing. But because the options exist, we need to specify exactly what part of it we want to use. And so that's a function call. That's a pattern you're going to find in modern graphics APIs, and it gets worse and worse. With each new revision of the API, new options are becoming available to us. So you see this whole thing in DirectX 12. It's even more complicated. You see this whole thing in Vulkan, and the whole setup in Vulkan is just a lot of code because there's even more options there. So now we've created our render target and we've set up a render target view, we set up our viewport, we're all ready to draw. But what are we going to draw? We're going to need to send some data from the CPU to the GPU in order to draw anything. So how do we do that? In DirectX, we use something called a D3D 11 buffer. So a buffer is just anything that is a data holder. It's just a block of data. A buffer is like an area of memory that can hold data, different kinds of data. So first we create the buffer and we tell it how big we need it to be, and we tell it what kind of data is going to go in there. Buffer doesn't actually hold the data all the time. The buffer is a pipeline that lets us send the data to the GPU when we're ready to do that. When we're ready to, we need to map our buffer. What mapping means, really what that means is give me an area of CPU memory that I can write to. I can fill in my data in this location. And then later, when I'm done, I'll say unmap it. And when I unmap it, that says, okay, I'm done writing to it. And that will cause it to send that data over to the GPU at that time. And once it's done with that, then I can have that memory back. Okay, so what do? I have a buffer. I create a buffer. I want to send that buffer over to the GPU. So what do? It's first I map it. And then once I've got it mapped, I fill in the address that I get. In here, this is the resource that I want to map. My D3D11 buffer is a resource. So I'll put that here, and then I will get back, see this is an output variable, I will get back the mapped resource, and in there is the address that I'm allowed to use. So I will use, I just say a memcopy, good thing to use. Just use a memcopy or something like that to fill in that address with the data I want to send. And then when I'm done with it, I'll call unmap, and that's when it'll actually send it over. So I like to think of the map as if it were a malloc or new, because this is asking for an address. So I'll say, hey, allocate me enough space to put my structure. That's kind of like a new. And it'll put the space, the address will go into here. And then I'll say, oh, okay, now I have space to fill in my structure. I fill it in, and then you say, oh, okay, I'm done. And when you're done, you would, of course, free or delete your structure. And that's sort of analogous to calling this. All right, let's talk about the layout and get back to these semantics. Earlier, we pointed out these semantics that went on here. And this is strictly for the vertex input. This is the input to the vertex shader. These are our vertices. Okay, this whole topic I'm doing now, buffers are for all kinds of things. You put textures in buffers. You can put matrices in buffers. All kinds of stuff can go into buffers. But for the particular kind of buffer that has a vertex in it, we are going to use these semantics to hook up the vertices. So here's an example. I have this structure for my vertices. I have position and color. So here's a position and a color, there's a position and a color, a position and a color. I want to put the position on this semantic here to tell the GPU, hey, this vector 3 matches this float 4. And yeah, look at that. It doesn't even match the type exactly, right? I have 3 floats going into 4 floats. Okay, how about this one? The color 4, I'm going to stick it onto this float 4. And so I need to connect this element with that element. Here's a link for how to set that up. Let's take a look.
Here we are looking at this link talking about the input assembler stage. And there's lots of good resources here. We can look at how to create input buffers. We can look at the input layout, which is what we're going to be talking about here, and binding and specifying, etc., etc. So lots of links. What we want to talk about what I want to talk about first is this input layout. So here's a link to the create input layout function. Let's follow that. And here is the function itself and all of the parameters defined down below. It should be fairly easy to follow along through the SDK reference. So what we'll need to do is we'll have to have something called D3D11 input element desc or description, and there's a pointer to that, and it's even in the variable name. You see they put an S on the end, so this is an array, so it's a pointer to an array of them, and then how many is in that array, and then we're going to need a pointer for something from the shader, and etc., etc. So we can read what all of these parameters mean and how to do them. And going back here, they've got an example of something I wanted to show you, because I don't know if we've really ever covered this before, but I can make an array of just constant data by doing this. I just declare an array. I don't say how many elements are in it. And then I use the curly braces to just specify each one. So each one of these curly braces is one data element. Here's another data element. Here's another. And then I close the whole thing in curly braces, comma separated, and the compiler will automatically recognize that that is 3 of these layouts. This is 3 of these element descriptions, and it's just a really nice, concise way of writing constant data like this.
I got my input layout all set up. I've created my vertex buffer. Let's draw. We're ready to draw. We have vertices, we have a shader, we have the input layout set up. Let's draw. I'm going to need to set the vertex buffer that I created to be the active vertex buffer. So we'll use this function here. And then once it's been set, I can draw. And I need to tell it how many vertices I want to draw. So that's pretty simple. But let's take a quick look at these parameters here are a little bit weird. This one, first of all, that's a pointer again, but this is not an output. This is an input. So why is it a pointer? It's because it is setting us up to draw an array of vertex buffers. With a single function call, you can say, hey, I want to draw these 5 things. And so I'll put all 5 things into an array, and it'll draw 5 things. So you would put all 5 buffer pointers into an array of pointers. So this pointer here is saying it's an array of pointers. We just want to draw the 1, so just give me the 1 pointer, right? No problem. But because of this, again, is complicated extra option, that means that my strides is also a pointer because it expects that to be an array, and my offsets is also a pointer. Expects that to be an array. So that's what that says here. They're pointers because it allows it to be an array. We, in this lab, in our class, let's just do one at a time. Don't bother with the array thing, but you do have to pass it by address. So that means you can't just put the number 5 here, right? You have to put in the address. You can't put the address of 5. You have to make a variable. So just throw it on the stack, make a local variable, and pass that by address so that you can pass those.